Okay, last class we discussed about the pressures which influencing the glomerular filtration rate or glomerular filtration. We came to know that one positive pressure will be there and two negative pressure will be there. One is glomerular capillary pressure, that is the pressure exerted by the blood on the capillaries, which is a positive pressure and which promotes the filtration, whereas capillary hydrostatic pressure and as well as another one is what is that? Uh, 1 second. Yeah, glomerular osmotic pressure. So these two are the negative pressures which actually inhibits the filtration. So it is understood that lot of amount of proteins, whether it is a medium sized or large sized proteins, if it is present in the blood, then obviously the filtration rate will become slower. Whether it is an advantage or disadvantage, we cannot say now, right now. Depending on the person, it may become advantage or it may become disadvantage. Obviously, we require proteins in the blood, but high concentration of protein in the blood or very low concentration of the protein in the blood, so both are problematic conditions here. So this glomerular osmotic pressure, the protein content in the blood, so obviously it will decreases the filtration rate or glomerular filtration. So let us go through the which one glomerular filtration rate. Yesterday while leaving we discussed that is the amount of the fluid filtered through the glomerulus in both the kidneys each minute. So already we discussed like 2 millions of nephrons will be there, and all these nephrons are going to filter the blood, and per minute 125 ml of filtration will be there, and as well as a filtrate will be there in case of male, and 105 ml per minute is the glomerular filtration rate in case of female. This is for 1 minute. Of course we like all this 125 ml or 100 ml. It all depends on the amount of solvent and amount of this solute. So that concept we are going to discuss later on. So partially we discussed earlier, like minimum 500 ml of the urine should form, or maximum 3500. The meaning is, so how much amount of the water is required to dissolve the solutes. So that is minimum 500 ml. Like 1500 ml is ideal to dissolve the waste products which are generated in the body. So that concept again last at the end we are going to discuss. Now the point is, if glomerular filtration rate is very high or if it is very low. So definitely both are problematic. For example, if glomerular filtration rate is very high, consider if it is like around some 200 or something like that, then what will happen? You just go through this diagram, you will get a clarity. Very high glomerular filtration rate. Consider some 200 or 300 ml per minute is the glomerular filtration rate. Then the fluid will be moving very fast in the tubule, and there is no chance of reabsorption. Who is Prakruti? Prakruti, please mute. So very high filtration rate, for example, around some 200 or 250, then the filtrate will start to move very fast, and there is no chance of reabsorption, because sometime the fluid rate, that means the flow rate of the fluid should be ideal. So thereby, if very high levels of glomerular filtration rate, obviously we cannot reabsorb the content from the tubule. And finally, what will happen? The excess amount of urine will get excreted from the body. Even the essential nutrients will get excreted from the body. Consider if glomerular filtration rate is very low. Consider if it is like around some 60 or something like that. Then the fluid will start to move very slowly. Then even the unnecessary content, that means waste products or toxins, will get reabsorbed into the body. So this is the advantage. The disadvantage is what we come across when the glomerular filtration rate is very high or very low. So ideal is 125 ml per minute is the ideal. So you cannot expect that every time it will be 125 ml. Sometimes it will, most of the time it will get fluctuated, but it will get repaired. How? We will see here. Now let us go through one by one. First one is renal autoregulation. So when in the renal autoregulation, first one, two mechanisms are there: myogenic mechanism and tubuloglomerular feedback. So this first one is very easy. Myogenic mechanism, when renal blood flow is very high, then obviously what will happen? The glomerular filtration rate will be very high, because more amount of the blood will be reaching the tubule. That means through afferent arteriole, more blood will be reaching the glomerulus. That means Bowman's capsule. So what will happen? That increased glomerular filtration rate will be there. Then what happens? Then you heard about blood vessel tunica, what I can say, composition of the blood vessel like tunica externa, tunica media, and tunica interna. So once the flow is increased, automatically the blood vessel, what it will do, it will promote the contraction of the muscle fiber. That means middle layer. So thereby the blood flow will get decreased, and then it will decrease the glomerular filtration rate. Similarly, when the renal blood flow is very low, for example, then it will decreases the glomerular filtration rate. Then and again the muscle will relax, and then increased blood flow to the kidney will be there, and thereby the kidney, what you can say, glomerular filtration rate will be decreased. Now you just go to the diagrammatic representation, it will give a better idea to you. For example, the blood is flowing, but the thing is the amount of the blood which is flowing is very high. This is afferent arteriole, and this one is efferent arteriole. So when increased blood flow is there, automatically glomerular filtration rate will be very high. Then what happens? Muscle automatically, what it will do? It will contract the, what I can say, blood vessel. So due to the contraction of the blood vessel, automatically the amount of the blood which is entering into the glomerulus, so it will get decreased. So once the amount of the blood decreases, so glomerular filtration rate will get decreased. And second example is if there is very decreased blood flow will be there in the which one, capillary, the arteriole, then glomerular filtration rate will be very low because the amount of the blood is entering is very low. Glomerular filtration rate also will be low. Then what will happen? The muscle will relax, and thereby the more amount of the blood will try to enter into the afferent arteriole, the glomerular filtration rate will increase. So this is the basic mechanism by which the muscle will alter. This is immediate. In few seconds, this will happen. That means remaining mechanisms, whatever we are going to discuss, it will take some time. So maximum some, for example, you heard about aldosterone system. I think you remember aldosterone. We discussed about aldosterone and as well as ADH. So that mechanism, at least it requires 1 hour time. 50 minutes to 1 hour time is required to, what you can say, to produce the action. But this mechanism, just some few seconds, some 5 to 10 seconds, immediately it will alter the diameter of the blood vessel, and thereby the flow of the blood towards the glomerulus will be continued, which can be controlled. So next one is the tubuloglomerular feedback. So under renal autoregulation, next we are going to discuss about tubuloglomerular feedback. So this is little complicated to understand, but I hope that you can understand this concept. Usually what happens, so I have drawn the, one second, you can see the nephron. So I have drawn the, in any textbook, if you see, the diagram will be like this. But actually it is wrong diagram. That means for understanding, we will give the diagram like this, nephron diagram. But actually it is wrong. So how it appears inside our body, the which one, nephron, you just go through one diagram, then you can understand, you will get a clarity. This is Bowman's capsule. This is proximal convoluted tubule, loop of Henle, ascending loop of Henle. Then it will take a turn like this. Then you can see that behind this Bowman's capsule, the distal convoluted tubule will travel, and then it will come back like this. I think you understand this one. You can see this diagram also. So the ascending loop of Henle, it will take a turn, and then it will move towards the, which one, backside of the Bowman's capsule. It will travel, and then it will come back. That means distal convoluted tubule, I repeat again, distal convoluted tubule, almost it will be very nearer to afferent arteriole, and as well as Bowman's capsule. Are able to understand this? You have to understand. Very important concept, this one. Distal convoluted tubule, you can see that this is the early part of the distal convoluted tubule. This distal convoluted tubule, it is very nearer to Bowman's capsule, afferent arteriole, and as well as efferent arteriole. Understood the concept or not? I repeat again, are you able to understand the diagram? Are you able to understand the diagram? That means, are you able to get the clarity about this diagram? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now, this is the diagram. That means this is going behind this nephron. That means this is what actually we are drawing. That means this type of diagram we are drawing. But actually, inside the body, this part of this one, that means descending loop of ascending loop of Henle, and as well as which one, distal convoluted tubule, it is behind the nephron, and then it is very nearer to afferent arteriole, and as well as Bowman's capsule. Now, what is the meaning here? That means constantly this distal convoluted tubule, we will understand this distal early part of the distal convoluted tubule, constantly it will be communicating with the afferent arteriole and as well as efferent arteriole. then the question will come into your mind that how it will communicate with afferent arterial, and as well as Bowman's capsule. That should be your doubt. For that, you have to understand one more concept. Now you just go through here. This is a normal diagram what we draw. This is the Bowman's capsule. This is the, you know that this is a proximal convoluted tubule, descending loop of Henle, ascending loop of Henle. Then this stretch, can you see the stretch? So this is the early part, that means the end, last part of the loop of Henle and early part of the distal convoluted tubule. So this part is something special. This part contains specialized cells. Some specialized cells will be present in this part of the nephron. They are called as macula densa cells. I repeat again, this part, that means early end part of the loop of Henle and early part of the distal convoluted tubule contains specialized cells. They are called as macula densa cells or macula densa region. This region is called as macula densa region. This macula densa region, so constantly it will be in contact with the which one? Bowman's capsule. Now you can go through the diagram. It will be in contact with the Bowman's capsule. It will be in contact with afferent arterial. I'm not telling that physical contact. That means it will not be in contact physically, but continuously it will be sending. It will take the feedback and then it will send a feedback to which one? Afferent arterial. I repeat again. Listen carefully. Constantly, this area, it will get the feedback through filtrate. I repeat again, filtration will be there. Filtrate will be moving like this. Filtrate will reach this area. It will check the filtrate. Which one? Macula densa region, it will check the filtrate. And then based on the type, what you can say, composition of the filtrate, based on the composition of the filtrate, it will alter the afferent arterial or Bowman's capsule. Then you should get one doubt, how it is going to alter the functions of afferent arterial, and Bowman's capsule. So as I told you that these are specialized cells, continuously based on the concentration or composition of the filtrate, it will release certain chemicals. They are called as paracrine signaling. It is called as paracrine signaling. What is paracrine signaling? For example, if any one cell, it communicates with another cell by releasing certain chemicals, and those chemicals will communicate with another cell. That is called as paracrine signaling. So two types I will discuss. One is autocrine, second one is paracrine. Autocrine means self. That means the cell itself will release the chemicals and thereby it will alter its function. This is second example. That means the cell will release some chemicals, and those chemicals, what it will do? So this proximal distal convoluted tubule, that is macula densa region, it will release some chemicals. It will influence the afferent arterial and it will influence the efferent arterial. So that means you have to understand that the chemicals which are released by the macula densa region, and those chemicals will have the receptors in the afferent arterial and as well as efferent arterial. By releasing those chemicals, it can alter the diameter of the afferent arterial and it can alter the diameter of the efferent arterial. Followed or not followed? Or shall I repeat? If you have not followed, anybody not followed, tell me to repeat, I will repeat. This you have to understand. Very important concept, this one.
Repeat, sir.
Shall I repeat?
Yes, sir.
Okay.
Yes, sir.
Okay. You just go through this one again. So this is a macula densa region in the early part of the distal convoluted tubule. They are specialized cell. The speciality of this cell is it will assess the filtrate. It will assess the filtrate, what it contains, the composition of the filtrate. It will assess based on the type of, what you can say, composition of the filtrate. It will communicate with the help of some chemicals with which one? Afferent arterial and as well as efferent arterial. So again, I repeat, distal convoluted tubule, early part of the distal convoluted tubule, it is composed of one specialized type of cells called as macula densa cells. Based on the composition of the filtrate, it will communicate with the which one? Afferent arterial and as well as efferent arterial by releasing certain chemicals. What are those chemicals? I will discuss later on. Whether you followed this concept or not, that is important. Actually, you should get two doubts here. Doubt number one. So what actually it will check? That means I told you that it will check the filtrate and then it will communicate. What actually it is checking? That is the first doubt. Second doubt what you will get is what type of chemical it will release and how it is going to influence the diameter of which one? Afferent arterial and as well as efferent arterial. That I will give clarity. Right now, what you have to understand in this slide, whether you followed the concept or not. What I mean to ask you, this macula densa cell, it will assess the filtrate. That means it will check the composition of the filtrate. They are highly sensitive to filtrate, and based on the composition of the filtrate, depending on the requirement, not every time, depending on the requirement, it can communicate with which one, afferent arteriole and as well as efferent arteriole. Whether you followed this concept or not, you tell me. Yes or no?
Yes, sir.
Okay.
Yes, sir.
Now I will proceed. So now this is a macula densa. So what actually it will check? Now you assume. Now everything is assumption now. So carefully you listen. Actually, what is the assumption here? Consider what is the, then you know that the glomerular filtration rate is 125 ml. Glomerular filtration rate is normal is 125 ml. Consider it is around some 60 ml or something like that. Okay, 60 ml or 80 ml. Now the filtrate is moving very slowly because the glomerular filtration rate is very low. The filtrate is moving very slowly. When it is moving slowly, what happens? Maximum amount of the ions and as well as water will get reabsorbed in this area. That means it may be sodium or chloride or potassium or water. Everything will get reabsorbed very fastly. Why? Because the filtrate is moving very slowly. So that's why more time will be there for the filtrate to get reabsorbed. That's why even though normally that much filtration will not be, reabsorption will not be there, but maximum reabsorption will be there because the amount of filtrate is very less. Glomerular filtration rate is low. That means reabsorption is high. Listen carefully. When filtration is high, reabsorption is low, excretion is high. I repeat again, when filtration is high, reabsorption is low because the filtrate is moving very fast. So that's why reabsorption is very low. That means excretion is high. Consider when the filtration is low, reabsorption is high, excretion is low. I think you understand the concept. So more faster the filtration, consider more filtrate is formed here. Some consider some 200 or 250 amount of filtrate is formed. That means it is understood that the filtrate is moving very fast. When the filtrate is moving very fast, then there is no question of reabsorption. Very low reabsorption will be there. That means maximum amount will get excreted out from the body. I think now it is winter. You can understand. That means the filtrate, that means the glomerular filtration rate will be very high. So sorry, now it is summer. Sorry, now it is a summer. So the filtration rate is very low. Amount of the filtrate which enters into the tubule will be very low. Obviously, what will happen? Reabsorption will be high. The amount of urine will be very less. Consider the climate change. Now consider it is very cold winter. Then obviously filtration will be very high. Then filtrate will move faster and reabsorption will be very less and more urine will be passed. So this is concept actually. Now, when the filtrate is low, consider well, listen carefully now. The filtrate is low, consider some 60, 70 ml is moving. Then the filtrate is moving like this. More amount of sodium and water will get reabsorbed here. As more amount of sodium and water is reabsorbed, then the filtrate is moving like this and it reaches the macula densa region. Then this macula densa cells, what it will do? It will check the filtrate. So actually, when compared to the normal quantity of the sodium or chloride or water, less quantity of sodium, chloride, and water will be present. That means the filtrate is a deficit of sodium, chloride, and as well as water. Then immediately, macula densa region, it will sense it. That means very less sodium is present. Very less sodium is present means what? Then when less sodium is there, it can understand that there is something wrong with the filtration. Then it can understand there is something wrong with the filtration. So that's why less amount of the sodium and water is coming here. Then what is the remedy? So this macula densa, what it will do? It will communicate with afferent arteriole. It will dilate the afferent arterioles. So thereby, so what will happen? It will constrict this particular afferent arteriole. So thereby, it will try to control the amount of the blood which is reaching this particular area. Then by releasing some particular chemicals called as paracrine chemicals. For example, you heard about nitric oxide. So it will release nitric oxide. That means nitric oxide and ATP will have the receptor on the afferent artery. Then actually how it is going to what you can say manage. You just go through this slide. This is the what is that? Macula densa region. And then it will sense whether increased quantity or less quantity of filtrate is there, or for example, sodium or chloride is there. Then it will release renin. So this renin, what it will do, it will convert the angiotensinogen to angiotensin 1. So this is the angiotensinogen, it gets converted into angiotensin 1. This angiotensinogen is present in the liver. It gets converted into angiotensin 1. Then this angiotensin 1, it is released into the blood circulation. It gets converted into angiotensin 2 in the lungs. So because the enzyme called ACE, angiotensin converting enzyme, is present in the lungs. Already you studied this one in the blood pressure. Then angiotensin 2 will be released. This angiotensin 2, it enters into the blood circulation. What it will do? It will come and contract this particular efferent blood vessel. Efferent arteriole will be constricted by the angiotensin 2. What you have to understand, angiotensin 2 will have the receptors on the efferent arteriole, but not on the afferent arteriole. I think you understand. So only efferent arteriole will have the receptor for angiotensin 2. So this angiotensin 2 will bind to these receptors on the surface of efferent arteriole. It will constrict. Then what this will do, that means role on the which one, afferent arteriole, it will release macula densa region. It will also release the nitric oxide, and as well as which one, ATP. So nitric oxide is a potent vasodilator. Then it will promote the dilatation of this particular area. That means this will get dilated, this will get constricted. Thereby the filtration rate will be increased. Consider if it is an opposite situation, for example, blood pressure is very low. So then this condition will exist. Blood pressure will be increased. That means flow rate will be increased. Then automatically filtration rate will be increased. Consider if it is opposite condition, blood pressure is very high, then this will get inhibited. So all these particular things will get inhibited. So thereby the flow will be regulated by this particular, which one, hormones or enzymes, renin and as well as angiotensin mechanism. So this mechanism is applicable to tubuloglomerular feedback, because that feedback is given by the tubular region, distal convoluted tubule, that is macula densa region, and also role will be there in the hormones also. This is the hormone. Already in the notes I have given that hormone also will play a role. This is the first hormone. And one more hormone is there, atrial natriuretic peptide, ANP. Actually that hormone is present, hormone or protein which is present in the heart. I think you heard about heart that is divided into 4 chambers. You heard about right atrium. So through right atrium, blood will be entering into the heart. So immediately you near to right atrium, you heard about like pacemaker cells, that is like SA node. You heard about SA node. Next to the SA node, depending on the amount of the blood which is entering into the heart, as more amount of the less amount of the blood is entering into the heart, immediately next to the SA node, one particular specialized cells will be there. That will release one hormone called as atrial natriuretic peptide. And that hormone will be come out of the heart through circulation. It will come out, and then it will come to the kidney. What it will do is just to go through this diagram, then you can understand. Yeah. So this is the blood will be entering. What atrial natriuretic peptide will do, it will create the gap between the cells. More gaps will be created between the cells of the endothelium. So when the gaps are created in the endothelium, automatically leakage will be more. When the leakage is more, then automatically glomerular filtration rate also will increase. This is how it will act. Which one? Atrial natriuretic peptide. These are the different mechanisms by which the filtration will be regulated. So first one is a myogenic mechanism. That's what we discussed earlier, like increasing, contracting the blood vessel and as well as dilating the blood vessel. So this is the diagrammatic representation what we discussed. Next one is the tubuloglomerular feedback. So when there is a fall in blood pressure, then automatically glomerular filtration rate is decreased. So when glomerular filtration rate is decreased, increased reabsorption of sodium and chloride, and it is sensed by macula densa region of DCT, inhibits the release of nitric oxide, which is a vasodilator. That means what? So when nitric oxide is inhibited, then it causes vasoconstriction. Vasoconstriction of what? Vasoconstriction of afferent arteriole. And afferent arteriole will get inhibited. So thereby what will happen? The glomerular filtration rate will be regulated. So this is what we discussed here. So about the macula densa region. Now, this is the hormonal regulation. Now, any questions are there, you can ask regarding this one. It's mandatory you have to understand this concept. Are you listening?
Yes, sir.